Hello friends, this question is for the test series number 10. Subject name is analog circuit, topic name is operation amplifier and application. It's a 2 marks problem. Question says that what is the value of R? What is the value of R if the in the above circuit B minus and B plus are to be amplified by the same amplification factor? Basically, we have one V minus which is attached in the inverting terminal. We have one input V plus which is attached in the non-inverting terminal. So this amplifier will going to act as an inverting amplifier as well as a non-inverting amplifier. Question says that the amplification factor of inverting and non-inverting amplifier should be same. We know that if in any amplifier the input is attached to the inverting terminal of feedback resistor RF input RI, so in this case my amplification gain V0 by Vi is minus RF by Ri. Now if I have my system such that I still have a negative feedback RF by Ri, but this time input is directly applied to the non-inverting terminal. Okay, if this is my system, so my feedback gain is, so my gain is nothing but feedback gain, of course, is closed loop gain 1 plus RF by Ri. Okay, this is known as a non-inverting amplification gain, and this is known as a inverting amplification gain. Okay, so, but the question says that this non-inverting amplification gain and the inverting amplification gain is basically same for my case. Question says that choose this value of R such that your non-inverting amplification gain and inverting amplification gain will be same. Okay, so the thing is this: basically we need to find out the inverting gain and the non-inverting gain, and then we need to equate them, and then we will definitely get the value of R. That will be my answer, as simple as that. So first of all, I will take the case of inverting amplifier. For that, I will replace V plus as is equal to 0. If you replace V plus equal to 0, so you know that input current of the op amp is 0. So if the current is 0, then there is no voltage drop across the resistor, and your this terminal voltage will also be 0. Then you can relate this circuit with your first case. Okay, this is the case number 2. You can relate this circuit with the first case. You still have a feedback resistor which is 22k in your case. You still have input resistor which is 10k in your case, and your non-inverting terminal is grounded, which is 0. So your amplification gain is, in case of V minus, is nothing but minus 22k by 10k, which is minus 2.2. Now what you need to do, you will just going to equate the V minus equal to 0 and consider the V plus this time. If you consider the V plus, then you can see that okay, I have a feedback resistor RF which is 22k, I have an input resistor Ri which is 10k, and ground is also there, but my Vi is applied to the non-inverting terminal. But here my Vi is applied to a 15k resistor which is connected to the non-inverting terminal. So what we need to do, we need to first find out the voltage across this non-inverting terminal, because this will be my effective input Vi. So what we do, input current of the op amp is 0. So my 15k and R is in series. So my Vi is how much? R times V plus upon R plus 15k, right? So your non-inverting input gain V plus will be how much? 1 plus 22k by 10k times R upon R plus 15k, which is how much? Which is 3.2 times R upon R plus 15k. Question says that this non-inverting gain is equal to the inverting k, which is equal to minus 2.2. Okay, so basically your 2.2 is equal to your non-inverting gain. Okay, so basically question says that the amplified by the same amplification factor. So same amplification factor has been asked, so question is only asking for the magnitude. You don't need not to include the sign, because question is asking for the amplification factor. So it will be, you need to directly consider this as a simple 2.2 only. Okay, just solve this expression and you will get how much? You will get the value of R as 33 kilo ohm. Okay friends, 33 kilo ohm is my answer. So option C is my answer. Please students, consider this topic as very important, because every year you will have at least one problem on this op amp as an amplifier. Op amp has a various application as amplifier, as a mathematical operation device, as a filter, as a current to voltage converter. Okay, in which there is one of the very important application is op-amp as an amplifier, and every year you will have at least one problem on this of 2 marks most of the time. Okay, so please consider this as a very important topic. Thank you.